What do you think causes a rainbow? Created by Michael Portillo and Aldo Gonzalez. I always thought it was something simple, but in reality it's a lot more complicated than I thought. It deals with refraction, reflection, and dispersion of light. When light enters a water droplet, it refracts. Refraction refers to the bending of light. But why does light bend? Isn't light supposed to always be traveling at the same speed? Velocity is the distance traveled over time, and the speed of light is always traveling at 300 million meters per second. However, the distance that light must travel in air compared to inside a water droplet does differ. The reason that this happens is because in air, light has little to no resistance while passing molecules, but water molecules are more tightly compact, meaning it must travel around the molecules and no longer in a straight line. So if light travels through 1 meter of air in 1 second, then when light travels through 1 meter of water, it will take somewhere between 1 to 2 seconds, which is why a bending of light is seen. This bending is not only seen through water, it is seen through any medium that allows light to travel through it. A medium is any substance that can carry a disturbance or wave from one location to another. After light refracts when entering the water droplet, some of it will reflect and then refract again as the light exits the water droplet, meaning that not all of the light is used to form a rainbow, only the light that enters at a certain angle. The only light that we can see is the light that is between 40 to 42 degrees between our eyes and the rainbow, a cone shape. It is in between those degrees that we see the different shades of color. Sunlight gets refracted at every angle possible. Because of this, when viewing a rainbow, one can move and it will not disappear. The only way to make a rainbow disappear is to view it from an angle in which light is no longer between 40 and 42 degrees. This is why one can never actually reach the end of a rainbow. The moment one moves a step in any direction, they are viewing a different rainbow. But why does sunlight produce different colors? First, to explain the reason for colors, we must explain what sunlight itself is. Sunlight is an electromagnetic radiation and it releases various different wavelengths of energy, all at the speed of light. The full electromagnetic spectrum consists of radio waves, microwaves, infrared waves, visible light, ultraviolet rays, X-rays, and gamma rays, in an increasing energy order and decreasing wavelength order. The only type of wavelength we are focusing on is in the range of which visible light is emitted, which is between 380 nanometers to 700 nanometers, violet belonging to the shortest and red belonging to the longest. This is why violet and red are always on the opposite side of the rainbow, and the colors in between are orange, yellow, green, blue, and indigo from top to bottom. But why are colors dispersed in this order? The reason is because white light is a superimposed color of all the rainbow colors in one, but when white light reacts with the water molecules at an angle, forming a sort of prism, the different wavelengths refract at different angles. By refracting at different angles, the white light gets split up into colors and disperses evenly corresponding to the wavelengths, thus why a rainbow looks like a line of perfectly spread out colors. An important condition for rainbows, however, is that one must have the sun facing their back in order to see a rainbow. The sunlight has to pass overhead and then reflect back into one's vision. A question one might be wondering is, why does light refract and reflect in the first place? Why does it behave the way it does, and how exactly does light travel? Light used to be considered a particle because it could reflect, and the experiment set up used to back up their argument. However, then came an experiment called the double slit. This one in particular showed that light does not travel as a particle but as a wave. However, it cannot explain why light would get reflected. After several more experiments, researchers found that light is mutually exclusive, which helps explain why sometimes it acted bipolar. By mutually exclusive, it is meant that when light is acting like a particle, it cannot act like a wave, and vice versa. But how do we know when light will act like a wave or a particle? Light acts as a particle when reacting with matter, and acts like a wave when traveling through space and in between space. This theory agrees with all previous experiments and conceptual knowledge.
After understanding the concepts of rainbows and understanding how light works, we can conclude that rainbows can have other type of effects rather than an arc. So, what kind of rainbows exist? So, for starters, we have fogbows. A fogbow is a special type of rainbow which is formed as sunlight travels through a small cloud or fog and the fog droplets diffract the sunlight. The color spectrum in the fog is usually white, red, and blue. Fogbows are usually formed over a body of water or in an area with thin fog. Another type of rainbow is rainbow under the moonlight. Mostly when we think of rainbows, we think that it normally exists when there's sun around. But in fact, in some instances, rainbows can also form under moonlight. But these instances are extremely rare. On the few occasions where rainbows under moonlight are formed during a full moon or a near equivalent, these rainbows, which are also known as moonbows, are thought to display a single color but are made up of a spectrum of actual many colors. Due to the dullness of the moonlight in comparison to the sunlight, the colors are not visible to the naked human eye. Multiple rainbows are another type of rainbow, which is also rare. Multiple rainbows are normally referred to as double rainbows. As the name suggests, multiple rainbows are instances when there more than one rainbow occurs simultaneously in the same place and are made up of primary rainbows and other secondary rainbows. The region in between the multiple rainbows, which is unlit, is officially known as Alexander's Band, named after Alexander of Aphrodisias, a 2nd century peripatetic philosopher who described the band. Multiple rainbows are formed by the double reflection of sunlight. Inside rainbows are between 130 and 127 degrees in width. The reflection of white light takes place inside the color bands of the rainbows. High order rainbows are characterized with two basic groups, the primary and the secondary rainbows. The main determinant of this rainbow order is the number of reflection of lights in water droplets involving the formation of a rainbow. Primary rainbows are also known as the first order and are formed from one light reflection, while secondary rainbows are also as a second order rainbow and are made of two reflections. There are more other rainbows which are formed from more than two internal reflections, and these are known as high order rainbows. The number of internal reflections is not limited and runs to infinity, but the high order rainbows become less visible as the number of internal reflections increases. A monochrome rainbow is a type of rainbow whose color spectrum is based on a single color, usually red. Also known as a red rainbow, a monochrome rainbow is a rare meteorological occurrence and only happens when sunlight travels farthest through the Earth's atmosphere, during sunrise or sunset. Due to the great distance, short wavelength lines such as yellow, blue, and green are scattered and displaced from the spectrum, leaving only the red color. A monochrome rainbow has quite a drastic effect on the atmosphere. Full circle rainbows. With the right conditions, all rainbows are supposed to form a full circle, as opposed to the semicircular shape, or normally an arc that we see. However, several limitations brought about the sun position in the sky or obstruction of the sun by the landscape prevent the observation of a full circle. These limitations can be removed by moving to a higher altitude, such as tail of a building or probably in a board of an airplane, and a full circle can be observed. In rare cases, full circles can be made of primary bow and a secondary bow. Full circles rainbows can also be artificially made by spraying water mist through a hose when facing away from the sunlight. And this is how we end our presentation on rainbows.